welcome to Skyscanner, and it's probably a bit delayed to tell you about that. First, about us, who we are and what we do. Skyscanner is defined as a travel leader, travel platform that's present in many places. We have about 160 million monthly users between our web and our app platforms. It's usually the typical place where you tell your friends, hey, look up flights on Skyscanner, and it's the first time I've worked somewhere where I can actually tell people where I work and they understand it and they get it first thing. They don't understand what I do exactly, but that's a separate issue. I hope you do now by the time we finish this session. And yeah, we have web, as I said, Android, iOS native apps, and then we do a bunch more stuff, but that's the core of it. I'm going to try to fix the feedback because I think it's a bit annoying, so give me a second. Is that any better?
Yep.
It seems like it. So, nice. So today we're here to talk about the iOS app, and we'll give you some insights in how we handle migrations, that being both technology, meaning language migrations, but also UI migrations. So I'll be in charge of the first one. My colleague Sohail will be in charge of the second one. So I don't have cool historical pictures of myself, just like Brandon did. But in 2000, I was 3, so I don't have much to show. So we'll stick to the app for now. I do have some history about the app, which is really cool. So where did we land in the current state of the app? This, to my mind, pretty good looking, nice, slick app, well designed, that makes all this stuff and where you can look up flights. Let's go back to the very beginning, all the way to 2011, actually, which is when the Skyscanner app was actually released. That was February. And yes, my memory of that time was seeing Messi lift Champions League, which was very nice. I do miss him. But the app, let's go back to the app. The app looked like this. It looked very iOS 4. And I don't know if anybody was, I think everybody here was probably around at that time. It was just very nice playing with apps, seeing the big, bold buttons, seeing everything, you know, the nice scrolling of iOS for the first time. That was a lot of fun. I had an iPod Touch at the time. I really loved it. So iOS, the Skyscanner app launched on iOS. It only handled flights at that time, which will be relevant later on. And yeah, it came to very good reception from, of course, the back of Skyscanner itself, which at the time was just a web platform. Moving along to around 2015 to 2016. Can you guess what happened at that time? Yes, another Champions League. I didn't put the picture here. So about Skyscanner, Skyscanner acquired a startup that was in charge of developing a hotels mobile app, and then it integrated that into the app, making it a 3-in-1 app, which is flights, hotels, and cars. And so it could do everything, like, you know, this 6-in-1 stuff that we use at our homes and hopefully cars. And that means that, you know, that app was probably written in Objective-C at the time. I don't know about Android, probably Java and all the nice stuff they have over there. But that means we probably carried a lot of stuff already from 2011. That's 5 years of development, right? And you know that a lot of stuff happened in between. So after this, we also ended up integrating React Native into the app, mixed in with the fully native parts. And along the way, thankfully, I must say, we also got rid of that. So we don't have it at the moment. It was shortly after I joined, so I'm happy about that. And that leads us to where we are now. So where are we? We have a UI kit core in the app, which for the foreseeable future will maintain, but of course, everything is pointing to Apple, forcing us to eventually change that. We manage dependencies with CocoaBots. The total size of the code base is about 900 lines of code. And yes, there are some Objective-C dinosaurs laying around. We also have a very nice design system, which is part of a separate repo. This is actually open source. You can check it out on both iOS and Android. And so Sohail will be going into that in more detail. And again, I apologize about the hissing. It's a bit annoying. So this is where we are, but where do we want to go, right? Because again, the app needs to keep serving all those millions of travelers. It needs to keep working. We need to keep delivering features. But we also want nice things to work on as developers, right? So eventually, we know Apple will probably not just kindly into the direction of having a Swift UI core. We will probably want to use something different for dependencies, probably Swift Package Manager, although I'm being told there's other nicer solutions around, so we should probably keep an eye for those. Removing Objective-C, and then, as I said before, in the meantime, while we do this, continuing to delivering features and continuing to improve the product, right? Not disrupting that. And finally, updating the visual language, because the design is always evolving, so again, Sohail will be giving us a very good input into that later on. And in this talk, we'll be focusing on the Objective-C part and the design part. So, yeah. Oh, thank you. Nice tip. Apparently, if I put the microphone forward, it's better. So, let's begin with the Objective-C and how we're getting rid of it. We haven't yet. Spoilers. So, there are some dinosaurs in the code base, as I said, and they are quite noticeable. So, we went at the beginning of this project from a state where we already had quite a bit of the app already in Swift, so about 93%. And that means just 7% Objective-C. And we want to get to a state, of course, where we get 0. And that means a better developer experience. That means lots of nice things that we like as engineers, right? We encounter something made in Swift, we understand how it works, it's straightforward, it's consistent, it's nice, strongly typed. But there's more to that than just the developer experience, right? There is, again, understanding the code much more easily. We had parts of the Objective-C code that nobody understood, because again, nobody was around from 10 years ago, most likely, right? So that's something that caused it. And of course, we had operational surprises, incidents caused because of many of the particularities of Objective-C and the way it works. So how do we get there? And how do we lay out the plan? Again, we're starting from 93. We want to go to 100. Should be fairly simple, right? Just add 7. Well, not as easy, right? With about 50 iOS engineers that we have at the company. Again, shipping features, working on CI, is not as straightforward. So we had a few, let's call them deadlines, let's call them temporal anchors that guided or that have helped us establish a plan for doing this in an organized way. First one is the CocoaPods deprecation. So it's going to be read-only by the end of this year. So by then, we should probably be migrated to SPM. And in fact, by then, we shouldn't have used many of the dependencies which are moving off it way before. Think something big. I think Firebase, I was told, is going to be moving away from it soon. That means, again, we have to remove all the things which are not in SPM at all. And we're using a bunch of third-party libraries which do. So we have to remove those as well. So let's keep going backwards. Something else we had internally, or much closer, was the iOS 26 release. And this is important because we hadn't yet migrated to UI scene delegate. And this is another interesting point we'll talk about later, but it's surprising, probably, that we didn't have it. I was surprised. But it's interesting to understand why and how we can do better, to be honest. And finally, as a self-imposed deadline as well, we also wanted Xcode 26 to compile against the new SDK so we could have some nice liquid glass to go along with the release. So that helped us establish 4 phases for the work we wanted to do for the Objective-C migration. And it's interesting because it helps us understand that it's not just taking the code, rewriting it in Swift, and calling it a day. And not just because of the amount of code, but because of how critical it is to maintain it in the right way. So let's break down the 4 phases. Number 1, as I said, was about enabling Xcode 26. So the most immediate thing we needed to get sorted. Moving from app delegate to scene delegate. This is a construct that's not that new on the Apple world. So basically, it's what allows apps to have multiple windows, multiple instances, allows nice things like app intents, as Anthony showed before, multiple windows on iPad, or amazing floating windows on Vision OS. We hadn't done this yet, so we had to complete this work. So again, learning there that should probably have been done before, and it's a learning from us to take things before they become fully deprecated. But yes, the liquid glass does look nice. We got featured by Apple in a couple of things, so we're quite happy about how that went down. Phase 2 was about removing all the dependencies which were legacy, either not even written in Swift in the first place, or only available in CocoaPods. And there's some fairly critical stuff there. So things like OSIMOC, polls, objection. We also had a Twix library to manage our flags, configuration flags in the app. or even things like the JWT to handle authentication in network calls. So pretty critical stuff that we have to pay attention to. Then phase 2 was around, or will be around, SPM migration. To test that out, to pilot it, we'll use our Backpack library, which is also in CocoaPods currently, to migrate it first to SPM, so we can use the learnings from that and port them into our main app. And finally, phase 4-ish, I would say, is the actual rewriting of code from Swift to Objective-C. So that means taking each and every one of the modules in the app, which is in the order of a few dozen, and migrating them by having a few steps that we laid down. So, and this is, I'm a bit proud of it, but first mention of AI in this talk. We did use AI to assess the status of the code. Again, not just to look at the classes, the structure and stuff, to help us understand what it was actually doing, to be honest, because sometimes, again, it gets so long in the tooth that nobody really understands it. And this is key here. It helped us lay out a conservative plan. We then tried to cover every change with a feature flag. So for example, the authentication system, which was very critical, we did cover it and we did experiment first. We make sure everything is nice and stable. So again, that helps you understand why the timeline is kind of long from the beginning to the end, because every change requires experimentation, monitoring for at least a couple of weeks, I would say, in production. So that's the way we approached that specific part of the plan. We could probably talk about this as a whole talk, but again, feel free to reach out as well if you have any questions, because it's very interesting, but yeah, pizzas. So, where are we now? And I spoiled this a little bit. We are here, and by here, we mean about 96% of the way migrated. We probably won't get quite 100%, maybe by the end of the year, because we have some leftover header files, because of SPM, and we can go again into detail on that later, but we can get pretty close. And yeah, everything went really well, and we had no incidents, and it was great. No, of course not. We did have some learnings, we did have some mishaps. Again, the Objective-C dependencies being chained together in very strange ways with Objection especially caused us to not understand all this dependency injection, and so some bugs, some things did happen. Again, we can go in detail. But what I want to highlight here is how we approach these at Skyscanner. So as soon as we see an incident or a wrong line of code, we point out the line of code, not the committer of the line of code. It's probably Claude, but no. We try to fail forward, we try to be a no-blame culture, and so we learn a lot from it, even though we were in a bit of a tight timeline. And yeah, we'll be looking forward to understanding or learning more as we move towards a world free of dinosaurs and understand and apply all those learnings. So again, think about the cost of not migrating, not the cost of migrating. So we know we run a business, or at least Skyscanner does, and we have to prioritize features, we have to prioritize what we do, and many times that falls ahead of transitioning libraries and programming languages. But it ends up affecting us quite a bit. So that's probably something we should have pushed a bit harder and done a bit earlier. Next, we often underestimated the actual work to migrate some of the modules. So it was AI assisted, but still it was not that exhaustive, I would say. And finally, yeah, as I highlighted probably above, it became a business risk, right, to have all that legacy code. And so it requires priority, it requires somebody really pushing for us to migrate the code and to own that workstream, because otherwise it's hard to fit it in between other product deliveries. And that's about it for dinosaurs. So up ahead, I will hand over to Sohail, who will talk about the UI migration.
Thank you very much, Dario. Can you hear me?
Yes.
Cool. Yeah, nice. Let's go. Yeah. So as any good-looking app, so we depend on a good structure for the UI to make it happen, right? So we have the same thing in the Skyscanner as well, and what we call that is the backpack, our UI design system that we have. So first, I'm gonna go through a little about what is backpack. So backpack is a sort of like our design system. It's a collection of reusable UI component that we have. And also we have a set of tokens like colors, shadow, and anything else that needs to be integrated with that one. And some guidelines and tooling, right? How we manage product design and then engineering for that, like a UI component that we have at the end. Cool. And why we are using the backpack instead of using just like native iOS component, right? Why we can use a text? So we can, but we don't want to. So there are like few reasons. One of them is that we want to have a single source of truth for like our design. So native iOS components can't like encode the Skyscanner brand. We want something more out of that. We need wrapper around that. And also backpack centralize all the tokens that we talked, spacing, behavior, and it ensures we have consistency between web, Android, and like iOS. So and that's like how we make it consistent. And also, as we mentioned, we have cross-platform alignment. It doesn't mean that if we need something specific on web, we force it to be the app-like. No, it's not the case. But as long as it makes sense, we go forward for that. And also, it helps us to have like a less maintenance cost over the long run. So, as I mentioned, it doesn't mean that we don't use the native components. We don't create the button, for example, by itself, right? Because it's just who wants to reinvent the wheel. But we make some wrappers around the existing components to make it happen. And so far, the adoption of the backpack in our Skyscanner app in both platforms is around 95%. When I say adoption, I mean that how much of this like a measured UI component actually being used in the app. So instead of using the back button, we use like a backpack button, and like we measure that with some like an analyzer system that we have in the app. But how this like a high adoption of our design system saved us over the time, right? So what is the benefit of that? So we had one example that like I brought here, and it's some new users like felt disjoint from the whole brand that we have for Skyscanner, and we wanted to refresh that for them. And it meant if we want to make such a thing, we need to change the entire app UI under the experiment, right? So yeah, we don't want to like make like loads of if else and all of like these conditions. So yeah, we wanted to make it like a proper way without the risk of incident. So we brought the experimentation on visual design language, and with the capability that we added as like a configuration layer on top of backpack, while we have this full adaption, we made it possible. So we went through the whole app to be refreshed by the new UI layer and with the new like a feel and look. But yeah, I'm sure you were looking for something related to AI. So let's say, what is AI here? Cool. So we know that AI is shaping the future, and we are aware of that in Skyscanner. Actually, we are trying to use it for productivity, innovation, and also having like a better user experience for our travelers, since this like a tools has been like emerged. And one other thing as well is that the limited of the like a number of like people that can work, right? We have loads of work, and we have AI. We say, okay, maybe we can mash them together to make it a bit like a less heavy and make it possible to work. So the first thing that we added in our like early days of the AI, we added AI instructions. So we had some policies, and we convert these policies to like some instructions. So whenever any like a agent gonna use that or any like a tool, so they can follow the standards that we have. And also for so low complexity task, we use AI to fully write that. So instead of we be the author of the code, we get the agent to write the code, and we just review that. And then we go through some feedback loops until it's done. But the main part that actually is recently that we were working on that was design to code workflow, right? So we know that this is like what we have about like a design to code. So we have some design, right? So we have some mock-ups that for us coming in the like a Figma is like the software that we use. Then it comes to the developer that manually wants to implement this code. Then developer need to review the produced code and match that with the design, right? To see that actually it is like similar to what we expect for. And finally, we write the, like some UI test or snapshot test for that. The step 4 can be like come back earlier if you use TDD. Cool. But yeah, we had some crazy idea. Okay, we said, what if AI could completely translate our design directly into the code? When I say the code, something that can be used as a draft for the production. So we don't want just like some code that is just a code that looks right and we are happy with that like a toy. We want like actual output out of that, right? And yeah, that's how we revamped the design to code workflow that we have fully with AI. So from writing the code to building and linting, testing, feedback loop is not loop, sorry for that, score, and also making gallery out of the like output that we have. So this 6-stage validation help us to fully go through and like a AI generated like a code that matches the design. So let's say this is our given design, right? This is the hotel card that we have. Probably you saw in the app, or you're gonna see that based on, I don't know, the delivery of that. But yeah, let's say we have this like a beautiful card, and then the designer said, okay, convert it to the code. And also consider that we have the back design system. So we can just use the button or any sort of that. We need to align with our design system while we go through that. So yeah, that's how it happened. So as you can see here, these are the generated code that designed by our the playground system that we built. And these are some iterations of that. So you can see multiple AI iterations that we have to convert that design to the code. But it's only one part of that, because not just generating code is important, right? We want to evaluate. So how good is the code? How good is the look, right? So these are the evaluation that without that, actually we can make sure that like when the feedback loop ends, for the AI is ended, right? When I want it to stop, when is good? So we need to measure what is good for that. And that's how we designed the like a system for evaluation based on 2 different like a metric. One of them is visual fidelity. So how closely the produced component matches the original design. That we use DreamSim and some other algorithm for that. And the second part was how code is close to what we expect from a good production quality code to be there, right? We want it to be there. We don't want just like making 1,000 lines of code that doesn't make sense and nobody wants to maintain. And also how this trustworthy UI automation AI workflow work is based on this deterministic feedback loops that we use full dev workflow in AI, as we discussed, via some sub-agent and skills as well that we use from the cloud. Now more AI like a tooling are just supporting that as well, and also enforcement via linting. So this part is very important as well. Though the AI instructions could help you to shape what is the output, but if you have enforcement via linting and then convert your meaning via linting, then the feedback loop that you have is 5 seconds, 2 seconds, comparing to 1 round of like running the code, right? And then making sure that it like aligns. And our learning was 3 main things we learned during this experiment. One of them was that with the right setup, we can achieve around 90% visual fidelity and code accuracy, which was something surprising for us as well. And the second part was that the Figma Code Connect could increase this design to code accuracy. So if the design system knows exactly what button means, what slider means, what each of these component means, then when they want to convert it via AI agent, they have much better time. They can do much better work. And also, the last one was that we understood that well-formatted design has so much better chance with AI. So designer could help you to have the right AI workflow here as well. Yeah, and that's it. Let's stay connected.
Thank you, Lyle. Any closing remarks, Ronan?
And are you gonna do some questions?
Or just everybody's too hungry?
Yeah.
I have one question regarding
Yes.
your pitch. Did you measure by performance tests your improvements?
So you mean about Swift Objective-C?
Yes. I mean, like any changes that you. So
what
to
do you mean by
understand,
that?
do you have a regression in the execution, for example, in the time complexity, memory complexity? What is the speed of this, or you didn't do this?
Yeah, not extensively, to be honest. We do have metrics around lunch times, times to results, loading, and things like this for the app itself. Those metrics seem to be stable, but that wasn't the focus really. It's a good question. That should be kept or at least improved.
Yeah.
Build times will probably up, to be honest, right? Because it's Objective-C to Swift, so.
So it was reduced actually build time, or
Up, I would say.
up.
Because the Swift is a lot more expensive. Yeah,
Yes.
takes longer. Yeah. Any others? If not, I'll hand over to Brandon and Anthony as well.
I have another.
Oh, go ahead.
So regarding the second pitch, how reiterations do you have to fit the design?
So I mean, this one or?
Yes, yes, from the side, yes.
Sorry.
Sorry, what was the question?
Yes, so the question is next. How many reiterations AI does, or you do, to fit the very close design that your designers provide from Figma?
So it depends on how model is good in converting that. We have a scoring, so the scoring helps you to see that how much it needs to go. If we reach to 90% fidelity, we just stop at that point because it's good enough for us. But we can have a separate a threshold. It depends on what needs to be defined by the C.
Okay, thank you.
Oops, feedback. Well, I think that's it for now, for this evening. We have some food there waiting for everybody. So once again, thank you very much to Skyscanner and for Brandon coming from WorkBrew for his presentation, and Anthony all about Swift MCPs. Thank you very much.